Alright, we have an interesting question to trash. We have 9 to the power of x plus 15 to the power of x, all this is equal to 25 to the power of x. So to be able to solve this, we are going to divide each of these terms by 9 to the power of x. So this now becomes 9 to the power of x plus 15 to the power of x is equal to 25 to the power of x. As I said earlier, divide here by 9 to the power of x, divide here by 9 to the power of x, divide here by 9 to the power of x. So by so doing, we notice that 9 to the power of x divide 9 to the power of x, which becomes 1. So now this one becomes 1 plus 15. Now this 15 can be expressed as 3 times 5, right, all to the power of x, because 3 times 5 is what? Is 15. Divided by 9 can be expressed as 3 times 3 all to the power of x. This is equal to 25 can be expressed as 5 squared, alright, all to the power of x, divided now 9 can be expressed as 3 squared all to the power of x. Now what I want you to let you know is that these 3 can cancel out. Now notice that this is 2 and this is 2. This is x and this is x. So we can single out the x and also the 2 in both numerator and denominator. So this equation now becomes, we are going to swap the side, which becomes 5 over 3 all to the power of these 2, because we have 2 in both numerator and denominator. So we have 2 multiplied by x. I'm going to have 2x. This is equal to, since this cancels out, you are left with 5 to the power of x divided by 3 to the power of x plus 1. Now we can also single out x here. Alright, so this now becomes 5 over 3 all to the power of x all to the power of 2. This is equal to now 5 over 3 all to the power of x plus 1. So we are going to let a particular variable to represent 5 over 3 to the power of x. Alright, so you can use any letter of your choice. Let me choose y. So 5 over 3 all to the power of x is equal to y. So anyway I see my 5 over 3 to the power of x, I will impute my y. So this one becomes, we are going to form a quadratic equation, which becomes y squared, right? This is equal to y plus 1, according to this. So let's form a quadratic equation. We are going to move y plus 1 to the left hand side, and so by so doing it will become a negative value, because it crosses equality sign. So this now becomes y squared minus y minus 1 is equal to 0. Of course, this is typical a quadratic equation. So to solve this, because of space, I'm not going to solve this. But if you solve this quadratic equation, the value of y will be equal to 1 minus root of 5 divided by 2. That is for y1. But for y2, we are going to have 1 plus the root of 5 divided by 2. Now notice that this is less than 0. So this is impossible. You cannot use this because you are going to get a complex solution. So our target is this positive value, because we only know that x is a set of real numbers. Okay, not a complex solution. So now we establish a statement that 5 over 3 to the power of x is equal to y. So anyway I see my y, I will impute my 1 plus root of 5 divided by 2. So now this equation now becomes 5 over 3 all to the power of x is equal to, our y day is 1 plus root of 5 divided by 2. Now whenever you have something like this, you cannot express it to be in the same base. So what we are going to do is to introduce the natural log to both sides, the Helen of both sides, or you introduce log to both sides. So we are going to introduce log to both sides. We are going to take the log of both sides in base of 5 over 3. So this now becomes the log of 5 over 3 to the power of x in base of 5 over 3 is equal to the log of 1 plus root of 5 divided by 2 in base of 5 over 3. Notice, log of the same base is always equal to 1. So when this x can multiply log 5 base 3, log 5 over 3 base 5 over 3. So log of the same base is always equal to 1. So that is equal to 1. So x times 1 is equally x, which is equal to the log of 1 plus the root of 5 divided by 2 in base of 5 over 3. So this is the required solution to this Olympiad math question. I hope you have learned a lot from this video. Help us to share, like, comment, subscribe, and follow us for more. See you. Bye. What do you